Okay, you're not going to be able to read my terrible handwriting, but that's fine. So our question is, Johnny's speed starts from 10 meters per second, which is pretty fast for a human, and that's like 20 miles an hour, so like Usain Bolt speeds. And then he's going to speed up for 2 minutes at 0.01 meters per second squared, which seems like a really low acceleration. But if you keep doing that for 2 minutes straight, that's not how most humans work, right? So this is not the most realistic problem. There is a bus 2.5 kilometers away. We want to know, does he make it, right? So this is back to a position time, position functions kind of question. So when I start reading these, I think it's a good idea to go through and like, what do I know? Or make a list over to the side or under here or whatever, but we need to make a list. So I know his initial velocity is 10 meters per second. I know his final velocity. I don't know. Not sure what his final velocity is. They don't tell me. I know the time, though. They tell me the time is 2 minutes. And we haven't used minutes all year in a problem, so I'm going to right away change that to seconds with some quick chemistry conversions of 60 seconds per minute. So look at that. We can even do that without a calculator. 120 seconds. We know this thing, he speeds up at 0.01 meters per second squared. And maybe you're like, what? Is that his final velocity? What? No, remember the units. Meters per second squared. That's an acceleration kind of thing, and he's speeding up at that rate, right? So his acceleration is 0.01 meters per second squared.
Good afternoon.
And let's pause. So then they mention this other thing. If the bus is 2.5 kilometers away, does he make it? So I'm not going to plug that in. That's a thing to compare to. When that tells me that what I want to solve for is position, my where does he go? So I want to calculate where he goes and then compare that to 2.5 kilometers, 2.5 thousand meters, right? So I go to my equations and I want to look for what's an equation that has all of this stuff in it and not a bunch of other stuff that I don't want in it. And I like that standard position equation, VIT plus 1/2 AT squared. You could certainly solve for his final velocity and then do an average velocity or something like that, but I think this is much more straightforward. We're solving for x. His initial velocity is 10 meters per second times 120 seconds plus 1/2 of 0.01 meters per second squared times 120 seconds, that whole thing squared. Right, so we do our math here, and that's going to give us 1,200 meters because my seconds cancel out. And that works because we want a position. So it's good that we see the seconds cancel out. 1/2 of 0.01 times 120 squared, and that gives me 1,272 meters. It doesn't look like they cancel, but I've got seconds squared here, and I've got seconds, and the whole thing is squared, so the seconds are squared there as well. Right? So we add those together, and that gives us 2,472 meters for our position. It says if the bus is 2.5 kilometers, well, 2.5 kilometers, we move our decimal point 1, 2, 3 places. That's 2,500 meters. That's a little more. No, despite the fact that this is completely inhuman speeds, 2 minutes is not enough time. 2.5 kilometers is a little over 1.5 miles, right? So no, even at inhuman speeds, like Captain America, he's not going to make it. But make your list, look to your equations. Which equation will this fit in? Pay attention to signs, right? Everything here is in the same direction, so it's all positive.